Hello, our objective today is that we will determine if lines in the coordinate plane are parallel, perpendicular, or neither using properties of slope. So what we need to remember is that if lines are parallel, then they have the same slope. And if lines are perpendicular, then they have opposite reciprocal slopes. So in order to determine this, we just need to find those two slopes and see if they're the same or opposite reciprocals or neither. So we're going to start with the first example. Line A passes through these 2 points and line B passes through these 2 points. To do this one, we're going to use slope formula. So I'm going to write M sub A, slope of line A, is equal to y2 minus y1. So that's going to be 6 minus 7 over x2 minus x1. So that is 11 minus 2. And this comes out to -1 divided by 9. Now I'm going to do the same thing with the second slope. So m sub b for line B is equal to y2 minus y1. So that is 5 minus 4 divided by x2 minus x1. So -22 minus -13, which is going to become a plus. So 5 minus 4 is +1, and -22 plus 13 is -9. What we have here is a slope of -1/9 and another slope of -1/9. It does not matter where the negative is in the fraction. So these are the same slope, which means these are parallel. So I'm going to write, therefore, parallel. Second example. Same basic idea, of course, but this did not give us two sets of points. This gave us two lines in slope-intercept form. So the slope of line C is 2. That's easy to tell because slope-intercept form has the slope as the coefficient of x. And slope of line D is +1/2, which is, again, the coefficient of x. So when I look at these, I'm checking, are they the same? Nope, so they're not parallel. Are they opposite reciprocals? Well, no, they are reciprocals, but they're not opposite reciprocals because they're both positive, so they are neither. So I'm going to write, therefore, neither. Third example, we have lines that are not in slope-intercept form, they're in standard form. So I'm going to rewrite each of these, solving for y so that it looks like the previous example. So line E, in order to get y by itself here, I would need to subtract 3x. So that's 9y is equal to negative 3x plus 36. Negative because we subtracted it. And then divide by 9, so we get y is equal to -1/3 x, because that's -3 divided by 9, plus 4. I'm going to do the same thing for line F, and if you're like me and you've done a lot of these and you think you can do it all in one step, please go ahead. In order to do this with line F, we would need to add 12x and then divide by 4, and that's going to give us y is equal to +3x and then plus 0 I'm not going to write. So we are now ready to just write our slopes. Slope of line E we found right here was -1/3. And the slope of line F, so m sub f is equal to +3. These are not the same, but they are opposite reciprocals because this is +3/1, which means we're looking at perpendicular lines. So therefore perpendicular. Finally, we get to line G and H. Now, both of these lines are a little bit different. They're y equals a number. You might remember from Algebra 1 a little acronym, HOY, VUX. This is just a quick way to remember if you have a horizontal line, it has a slope of 0 and its y is equal to a number. That's what we've got for line G. If you have a vertical line, it has an undefined slope, and it's when you have x is equal to a constant number, which is neither of these, but this is how you might be able to remember that. Both of these, in this case, y equals -3 and y equals 44, just have y equals a constant, which means they're horizontal and means they have a slope of 0. So the slope of line G is 0, and the slope of line H is 0. These are the same slope, therefore we are looking at parallel lines. If these had been 1, 0, and 1 undefined slope for a vertical line, then we'd be looking at perpendicular lines. So that is it. We looked at 4 different ways to determine slope, but all of them ended up just deciding if the set of lines was parallel, perpendicular, or neither.